Okay, so in this video, we are going to take a different scenario in which the population standard deviation is unknown and the sample size is less than 30. So previously, I suppose that before watching this video, you already have a knowledge on the z distribution, and we only make use of the z distribution. The first condition is that the population standard deviation sigma is known. Population standard deviation is known. And if in the case of, so this is sigma, if sigma is unknown, we can still use the z distribution provided that the sample size n is large enough. And when we say large enough, then that means n must be greater than or equal to 30. Now, since in the condition number 2 or scenario number 2, the sigma is unknown, that means we have to make use of the sample standard deviation S. So this is the sample standard deviation S. This is the standard deviation that you can get from the values taken from the sample. So sample standard deviation. So in the formula, if you remember the formula in getting the confidence interval, we have x bar plus and minus z of alpha over 2 sigma over the square root of n. The plus sign on the upper limit and the minus sign which will give the value for the lower limit. Now in this formula, in the margin of error, this is the margin of error, we need the value of the population standard deviation. In the absence of this, as we can see from the condition, if sigma is unknown, then that sigma can be replaced by S. So you use the sample standard deviation in place of the population standard deviation. Now in this video, we have a different scenario. So sigma, the population standard deviation, is unknown, and at the same time the sample size is no longer greater than or equal to 30, so it's less than 30. So for example, we have this data taken from 10 students, and these are the scores of the students in a particular mathematics course. These are the grades of the students. So as we can see, we only have 10 values, and that is less than 30. At the same time, we don't have any information about the population standard deviation. So in this case, we cannot use the z distribution. So what are we going to do now if the z distribution is not applicable? Okay, if you look at the structure of the problem, it's basically the same with what we do with the z distribution. You construct a confidence interval, and then we use that to make some interpretation. But how are we going to make a confidence interval if you cannot make use of the z distribution? Okay, so the solution is the t distribution, or what we call the student's distribution. Okay, so it's a different type of distribution, but it is similar to the normal distribution. So this will allow us to work on samples in which we have only less than 30, say, respondents or values. This distribution has the following properties, and it's very similar to the z distribution. First, it is symmetric about its mean. So if we cut the distribution in the middle, the left side will just be a mirror image of the right side, or vice versa. It has a mean of 0, so same with the z distribution. The characteristic number 3 is now different to the z distribution, because in the z distribution the standard deviation of variance is equal to 1. But for the t-distribution, the standard deviation and the variance is greater than 1. Now, there are many t-distributions as we will see later on, and that's depending on what we call a degree of freedom. So we're going to teach you how to get this degree of freedom later on. And as the sample size increases, the t-distribution approaches the normal distribution. So, again, we are going to use a t-distribution because we have a sample size that is less than 30. But given that the population standard deviation is unknown, but the sample size is large, that means the t-distribution will approach the normal distribution. That is the same reason why we can use the z-distribution if the sample size is greater than or equal to 30. Okay? Because the t basically approaches the normal distribution, so we just use the z-distribution when the sample size is large enough. Now it is bell-shaped, so same with the normal distribution. The t-scores can be negative or positive, but the probabilities are always positive. So there is no such thing as negative 0.1234 probability. They're all positive. Okay, so when we use the t-distribution, we will be using a different but very similar formula to the formula that we use for z-distribution in coming up with a confidence interval. If you just replace the t with a z and s with a sigma, then what we have is the formula for the z-distribution. Okay, so now that we are in the t-distribution, then the z is t, and the sigma now is replaced by s. It's basically the same idea. And once you know the formula, all you need to do is to place the value, the corresponding value for the t of alpha over 2. You may be required to compute for the standard deviation, okay, and then you have to know the sample size. And this group of expression is just the same as the one that we add on the sample mean to get the upper limit. Okay, it's basically a minus and plus, and that's how we will get the upper limit and the lower limit of the confidence interval. Okay, now next thing. Since we are now using a t-distribution, we can no longer use the z-table. And the t-distribution has its own table. So we simply call it a t-table. So how do we use the table? So first, in finding the confidence interval, so this is just one of the many t-tables that you can find online. But I selected this particular version because it listed the confidence level at the bottom. So when I say, or when a task is telling you to create a 95% confidence interval, all you have to do is to refer to that column in which you have, or which is under the 95% confidence level. If you will be asked to form or to construct a confidence interval using 90% confidence level, then follow the column for the 90% confidence level. Okay, now on the other side, on this side of the table, you see a lot of numbers from 1 up to 30, and then it starts to jump to 40, then to 60, then to 80. So as you can see, if you remember, what I said is we use the t-distribution when the sample size is less than 30. That is why the numbers here, the critical numbers that we are going to consider, are from numbers 1 to 30. Okay, so if I say the sample size is 20 or it is 10, then that number is under this range from 1 to 30. But how do we select the specific number? These numbers here are not the sample sizes, but it says here a DF. DF means degree of freedom. So to select the degree of freedom, the degree of freedom is basically the sample size less 1 or n minus 1. So if we have 10 values available from the sample, then the degree of freedom that we have to use is, so that's 10 as our n. So the degree of freedom df is equal to n minus 1, and that is equal to 10 minus 1 equals 9. So if I have to create a confidence interval with 95% confidence level with 10 samples, so that means I have to go to the df9, that's n minus 1, 10 minus 1, and then the number that I have to use to in place of the t of alpha over 2 will be 2.262, because that is the number for 95% confidence level and for the degrees of freedom, which is equal to 9. So that's how you select a number from the t table when you use a formula for the confidence interval. So in this example, we have 10 scores, so from the 10 students, our sample, and we are asked to construct a 95% confidence interval for the true average grade. So we're going to estimate the true average grade of the students based on the 95% confidence level. Okay, so using the t distribution formula, so we need to have the sample mean, which we can compute from the given values. You can do that by using your calculator. Use the statistics function of your calculator and find the sample mean. For the sample standard deviation, you also use your calculator to find this S, which is the sample standard deviation. If you want to know how to find the standard deviation and the mean using your calculator, there are many online tutorials that you can find in YouTube, and go search for one, and it's not difficult to follow. Okay, so I'm not going to discuss it anymore here in this video because it will take some time to explain that, because our focus here is on how to apply the formula under the t distribution. Okay, so let's proceed. So the formula is here. So once we know that we have to use the t distribution, then we proceed by applying the formula. So first we need to find the sample mean. Okay, so I'm going to use my calculator to find the sample mean. You can pause the video, do it on your own, and then you compare it to the value that I'll be obtaining using my calculation. Okay, so pause the video now to compute for the sample mean, and also you can already find the sample standard deviation as you find the sample mean. Based on my computation, the sample mean is 85.9. So list down the values that you have obtained. So compare it to my sample mean. The sample mean x bar is 85.9. The standard deviation, you have to use the S. So in most calculators, it's using the symbol SX, or some calculators will list it as sigma with an n minus 1, depending on the version of your calculator. So in my case, there is an SX, that is the sample standard deviation, and you have to write the sample standard deviation rounded off to up to 4 decimal places. So my SX, sample standard deviation, is 6.2973. So it's important to use 4 decimal places so that you can get a better estimate. If you round this off to 2 decimal places, then this becomes 6.30, and that change in the value will have a big impact in the final value of the interval. Okay, so keep the decimal up to 4 decimal places when you compute. Okay, now, so as we check, we have the sample mean done, we have the sample standard deviation done. Now let's find the t of alpha over 2. So in this task, we are supposed to create a 95% confidence interval. So that means our confidence interval is 95%, the alpha is 5%, so the alpha over 2 is 2.5%. Okay? So, but anyway, we are using the version of the t-table in which all we need to know is the confidence level. Okay, so I'm just listing this down so that you can get the relationship. When you write the t of alpha over 2, you know that you should write it as t of 0.025 because what we need is a 2.5%. Okay, but since we know that the confidence level is 95%, so when we go to our t-table and we have, if you recall, the number of students for the sample is 10, so the degree of freedom is 9. So that's exactly the number that we have found when I explained how to use the t-table. So the t of alpha over 2 that we need is 2.262. So we go back to our computation, and that means we have the t of alpha over 2. So you can list it down first. The t of alpha over 2 is 2.262. Now, to complete the values, the n is the sample size, so the n is equal to 10. So we're ready to compute for the confidence interval. Now, just like the formula for the z distribution, we can compress this formula into x bar plus and minus the t of alpha over 2 s over the square root of n, where the plus sign will give us the upper limit and the minus sign will give us the lower limit. So let's place the values. We have x bar to be 85.9 plus and minus the t of alpha over 2 is 2.262. The sample standard deviation is 6.2973, and then over the square root of sample size, which is 10. And we are ready to compute. Okay, so I'll compute the value. You can pause the video for now and then just play it again to reveal the final interval. So the confidence interval under the 95% confidence level is 81.40 to 90.40. So the true average score of the students is somewhere in between 81.40 and 90.40. By the way, you might have encountered a problem using your calculator if you you if you have not returned it to the normal mode. When you use the statistics mode of the calculator, it will change the way you write the fraction. So if you have encountered that problem, before you do the computation, you have to return it to the normal mode. So using the menu or the mode or the setup in your calculator, and make sure that you return it into a normal mode. Okay, you will know that it's already in the normal mode if you can express the fraction in this manner. If the fraction is using this symbol or this symbol, then that means it is not yet in normal mode. So you have to change it first or set it into a normal mode. Okay, so compare the values that you have obtained with mine. It's 81.40 to 90.40, and these are already rounded off to 2 decimal places. Like in 81.40, that's 81.3954. Okay, so going back to the problem, so we were able to do task A, and that is to construct a 95% confidence interval. So in letter B, there's the 95% confidence interval constructed in number 1 contains the average grade of 85. There's 85 within the interval. So our computation says it should be between 81.40 to 90.40, and clearly the average 85 is within the confidence interval. So that means with 95% confidence, we can say that 85 could be an average score of all the students who took the mathematics course. Okay, that means 85 is a valid claim. 85 is a valid population mean score of the students. But when one says that the score 92 is the average score of the students, and that claim is not valid under the confidence interval with confidence level 95% because it's already outside the confidence interval that we have created. Okay, so again, the key ideas in this video is that when the population standard deviation is unknown, first, you could still use the z-distribution provided that the sample size is large enough, and that is by when we say the n is greater than or equal to 30. But when the population standard deviation is unknown, and at the same time the sample size is less than 30, then we can no longer use the z-distribution, and instead we have to use a t-distribution using the new formula and also using a new table, and that is a t-table. Again, in using the table, you identify the confidence level, you refer to that column, and then identify the degree of freedom, and that is basically the sample size less 1 or minus 1. Like in this case, we have 10 students, so the degree of freedom is 9, which is 10 minus 1. And the number in the intersection of those two values, which is 2.262, will be the value that you have to use for the t of alpha over 2. Okay, so simply follow the formula and you can find the confidence interval as needed. Okay, so that's it.